The next topic is resistors in series combination. Let us consider three resistors R1, R2 and R3 which are connected in series. Series combinations means all the resistors are connected side by side like this, and this combination is connected to a battery. With the help of battery, we can provide a potential difference V across this combination. I is the current drawing from the battery. Same current can pass through all resistors. Here it is a single branch. So current passing through all resistors remains same. Now, according to Ohm's law, the voltage drop across the resistors, across R1, we can write the voltage drop is taken as V1. Across R2, the voltage drop is taken as V2. Across R3, the voltage drop is taken as V3. So, the total applied voltage is equal to V. The voltage drop across the resistors are V1, V2 and V3. So, we can write the applied voltage V is equal to V1 plus V2 plus V3. The applied voltage is equal to the voltage drop across all the resistors. Therefore, V is equal to V1 plus V2 plus V3. According to Ohm's law, we know V is equal to I into R total. So, you can write I into R total resistance is equal to V1 is equal to I into R1 plus V2 is equal to I into R2 plus V3 is equal to I into R3. Here I is common since current is same through all the resistors. So we can write I R total is equal to I into R1 plus R2 plus R3. Here I get cancelled. Now R total is equal to R1 plus R2 plus R3. Or simply you can write in series combination. In series combination, the effective resistance R in series combination Rs is equal to R1 plus R2 plus R3. R1 plus R2 plus R3. This is the effective resistance in case of series combination of resistors. Okay. Here, the current through all the resistors remains same. Therefore, the ratio of currents through all the resistors, I1 is to I2 is to I3 is equal to 1 is to 1 is to 1, because same current is passing through all the resistors. Therefore, I1 is to I2 is to I3 is equal to 1 is to 1 is to 1. Now, the ratio of voltages V1 is to V2 is to V3 is equal to, we know V1 is equal to what? I into R1 is to I into R2 is to I into R3. Therefore, we can write R1 is to R2 is to R3. Here I is a common term, I get cancelled. Therefore, V1 is to V2 is to V3 is equal to R1 is to R2 is to R3. R1 is to R2 is to R3. Now, you can write V is equal to I into total effective resistance, that equal to I into R1 plus R2 plus R3. Now we can write V1 is equal to I into R1. But you can write I is equal to V by R1 plus R2 plus R3 into R1. Similarly, you can write V2 is equal to again you can write according to Ohm's law V2 equal to I into R2. V2 is the voltage across a resistor R2. So voltage drop V2 is equal to I into R2. So that is equal to, you can write V by R1 plus R2 plus R3 into R2. Similarly, you can write V3 is equal to V by R1 plus R2 plus R3 into R3. So we can express voltage in terms of resistors and the applied voltage V. Here it is. Now, if n identical resistors are connected in series, that is R S is equal to R plus R plus R plus and so on R. N times n resistors are connected like this. Therefore, you can write R plus R that can taken as n times. Therefore, you can write n into R. Therefore, in series combination, effective resistance increases by n times to the individual resistance in this case. Hence, in series combination, effective resistance increases. So, this is all about series combination of resistors. Okay, have a look.